Hello and welcome to video 6 of Module 5. In this video, we'll be discussing conditional probabilities, and this time, instead of using two-way tables, we'll be examining these probabilities by using some formulas. Let's get started. The formulas that we're going to need for conditional probability are first going to look like this. This is the probability of x given that y has happened. And we can find it by taking the probability of x and y and dividing by the probability of y. Now remember, when I say the probability of x and y, that doesn't mean I'm going to take the probability of x and I'm going to take the probability of y and use both of them. Remember that x and y is a compound event, so it's going to have its own particular probability. So there's only going to be one number that we put in the numerator. Now, while this is our formula, I don't like this formula because you won't always be using x's and y's, and sometimes you will be using x's and y's, but in a different order. So if you have the probability of y given x, then this formula can be extremely confusing. So the way that I remember a conditional probability formula, it's a little bit longer to write out, but it makes a little bit more sense to me. It's the probability of an event given a given. To find this, you're going to take the probability of the event and the given, and again, this is just one probability on the top, and divide by the probability of whatever you were given. In other words, that second piece of that probability. Then, if we manipulate these formulas, we can rearrange it to find the probability of x and y, and this will be the probability of x given y times the probability of y. Let's do an example of applying these formulas as well as some formulas we may have seen before. In this example, suppose we know the following information. The probability of A is 0.32. The probability of B is 0.50. The probability of C is 0.92. The probability of A and B together is 0.16. And the probability of C, given that B has happened, is 0.96. And now we're going to determine a bunch of probabilities. For the first one, we want to determine the probability of A given B. To help us out, I put together a menu of all of the different formulas that we've had. The first three formulas we saw in a previous video for compound probabilities. And then the second two, or the last two rather, are the ones that we just mentioned. And I've used the probability of the event given the given instead of using the x's and y's, since, as I mentioned, I find this form of the formula a little bit more useful. So for part A, we need to find the probability of A given B. When I look at my list of formulas, I need to find the one that says the probability of a conditional. And that's going to be the fourth formula in the list. We have the probability of an event given a given. So when I look at my formula, the numerator is the probability of the event and the given. In this case, since my event is A and my given is B, I need to find the probability of A and B. In this case, this is the 0.16. A reminder that this and probability is just one number, so I don't use the 32 or the 50. Because for the probability of A and B, it's going to just be that 0.16. This is going to be the numerator of my solution. For the denominator, I need to find which value was given. Remember that the given is the second condition. So in this case, B is the given condition. So I look up at my information, and the probability of B was 0.50. So that means my denominator is going to be 0.50. Once I've substituted into the formula, now I can simplify. So I'll do 0.16 divided by 0.50, and I end up with 0.32. Let's do another example. Example B says the probability of B and C. This time, when I look at my menu of formulas, there are actually two of them. The first one says the probability of x and y equals the probability of x plus the probability of y minus the probability of x or y. The second one says the probability of x and y is the probability of x given y times the probability of y. When you're presented with finding a probability and you have multiple ways of finding it, we need to determine which of these formulas is going to be the best one for us to use. When I look at the first formula, I know that I have the probability of x, I have the probability of b, and I need the probability of y, and I do, I have the probability of c. But the third piece of that formula, the probability of x or y, when I look up at my given information, I have the probability of A and B, and I have the probability of C given B, but I don't have the probability of B or C. That's not listed at all. I don't have any or probabilities. So because I don't know that, I can't use that formula. I don't have enough information to be able to use it. So hopefully we do have enough information to use the second formula. In the second formula, we have the probability of y, which we have. We have both the probability of b and the probability of c solo. So we have those. The fancy probability here is a conditional probability involving the two letters. So I look up at my pieces of information, and I have a conditional probability. I have the probability of c given b. Now, if I also had the probability of b given c, instead of C given B, if I had the other order, it would still be fine. What this formula says is I need to have a conditional probability that involves both of my variables. Since I have this, this is going to be the start of my formula. Hooray, I can use it. So I'm going to write down the 0.96 because that's the information I have. For the second part of this formula, we need the probability of y. Now notice that in the formula, the y corresponds to the given piece of information. So when I look up at what I've highlighted in red on the left, the probability of c given b, the b is the given information in this probability. So that means I need to find the probability of b. The probability of b was 0.50, so that is what I'm going to multiply by. When I multiply it out, I end up getting a 0.48. Now, in this case, if I had been given the probability of B given C instead of C given B, if that order was reversed, I would have taken that conditional probability and multiplied by the probability of C, because the conditional probability I would have known would have been a C as the given instead of B. So this is one of the reasons, again, using the X's and the Y's can be a little bit tricky. So think about what you've been given and the order of things that you have for conditional probability. Now let's review a few of the older formulas. For this example, we want to find the probability of A with that little c. Now remember that little c doesn't mean an event of c, doesn't mean A to the c power. It means the complement of A. So the formula for the complement of an event says take 1 and subtract the probability of the event. So the probability of A complement is going to be 1 minus, and then we subtract the probability of the event. In this case, the probability of A. So we'll subtract 0.32, and we end up getting a 0.68. All right, let's do one more example together. Example D says find the probability of A or B. When I go to my menu of formulas, the second one involves the or, X or Y. In this case, X is going to be played by A, and Y is going to be B. So wherever I see X's, that's A. Wherever I see Y, those are B's. So my formula says the probability of X, in this case meaning the probability of A. So we're going to take the 0.32. Then we have to add the probability of Y, in this case the probability of B, and we'll end up with plus 0.50. And then we have to subtract the probability of X and Y. Remember, the probability of x and y is its own unique little probability. So we're going to take the probability of A and B together and subtract it. When we carry out the computation, we end up getting a 0.66. That concludes our video about conditional probabilities using formulas. If you'd like to review conditional probabilities using two-way tables, you can click on the arrow to the left to view that video. In our next video, we'll be discussing something called independence. So we'll see what it means for two events to be independent. And that's going to build on this idea of conditional probabilities. Thanks for watching, and have a great day.